Afternoon. Here we go. Cruising along now. Our present time, 163 hours, 52 minutes, and 22 seconds. Verb 37, enter, 30, enter. Uh, 16517 5956. Proceed. Six nine four 1585.6 182.7. Looks good. Proceed. Two four three five 90.5 DVC. Ah, that's interesting. One 5856 1827 694. Looks good. Two four three 0.2 91.3 15976. Proceed. 00. Enter. Okay. External delta V is plugged in. Cruise right along to the P52 IMU realign. Verb 37, enter. 40, enter. Proceed. Verb 34, enter. 00, enter. Verb 37, enter. 52, enter. Looks good. Preferred option, yes. Proceed. And we've got stars. Center out right here. Good. Verb 32, enter. Proceed. Looks good. Okay. Mark sequence. How is everyone today? Star 40. Careful. And mark. 42. Mark. I'll take that again. Mark. That's better. Okay. Looking good. IMU adjustments are complete. That would just leave us with the manual control burn. And we are good to get that clock. That clock synced up. better. Okay. Performing the P40 manual thrust control SCS SPS. So this starts out the same as before. We always do our external delta V and our P52s. Since they're always the same, I've done them, and we're now up to the lamp check. So the lamp check is complete. Delta V set, and we're going to set for the compensated delta V here, same as always, 1680.4. 1680.4, and set delta V. Bmags are on rate 2. CMC free while we get our RCS activated. So the burn configuration. Verb 24, enter. 10102, enter. We'll use AC, so 11111, enter. Proceed. The weight is verb 21, enter. Plus 30,656 pounds, enter. Proceed. And our trim for the burn, verb 24, is minus 000.78 and minus 0.45. Enter. Proceed. Okay, now that that is done, we'll call verb 46. And we've got our digital event timer set. Verb 37, enter, 00, enter. CMC auto, verb 49, enter. And we just key in the attitude for the burn. So 0, 0, 0. Proceed, proceed. And now the spacecraft will be maneuvering itself. Okay, maneuvering to burn attitude. All right, steady out. 50-18. Looks good. And now we just need to drift here for a few minutes. So we'll actually go SCS for this, and we'll just drift along. Until about 15 minutes. Here we go. Go back to CMC. And we do our sextant star check. 0 switch off, CMC. Verb 41, now 91, enter. And our angles for this star are plus 105, plus 105, 05, enter. Plus 09340, enter. And if all goes well, we should be looking at one of the stars, but of course, mission control in here can't factor for the Earth's orientation, so that's okay. I have confidence in the burn attitude. So recenter that out. Verb 37, enter. 40, enter. And let's bring us down to the 10-minute mark. At the 10-minute mark. Proceed, and we'll transfer attitude control over to program 40. We'll close our direct ullage circuit breakers and our pitch and yaw circuit breakers. Translation control on. And we'll bring us down to the 6-minute mark. Six minutes. Main bus tie is on. Thrust vector control servos on. Rotational control power to AC only. And begin SCS attitude hold. Bring it down close to 5 minutes. Pitch motor 1 start. Yaw motor 1 start. Manual control engaged. Verify no manual thrust vector. Good. CMC attitude hold. Pitch motor to start. Trim check. Trim is good. 5, 6, 7, 8. And 5. Looks good. Manual thrust vector control is showing good. Engine is gimbaling. I like to look at the outside. All is well. Manual thrust control disengage. Rotational control power, AC/DC. Direct on. Rate 2. Transfer attitude control back to P40. And at 1 rate 2. Computer control check. Rate scale 5-5. Rate high. SPS helium valves in auto. Check complete. Standing by for trim load. Trim load complete. 3 minutes to the burn. Okay, so we're going to start this burn in auto, and at the 36-second mark, we are going to take over manual control. So it's sort of simulating a computer control failure. If we start drifting out of attitude and we notice that, we go manual and we take control. A good tip for this is holding control and using the arrow keys is a good way of maintaining control of the engine. If you do not hold control, the spacecraft, if you're using mouse and keyboard, assumes you're doing hard over commands. So it's good to always hold control. And this only gimbals the motors at most 5 degrees at a time. Whereas not holding control will hard over the engine. So that's something to keep in mind. We'll bring it down to 2 minutes and we'll arm our thrust. Preparations for manual burn are complete. Two minutes, and the thrust is armed. Taking it down to 35 seconds. 35 seconds, and we get the disky blank. Here we go. EMS is monitoring thrust. No ullage for this burn. 20 seconds. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. Confirm the burn. 3, 2, 1. Ignition. Clock start. Ready to take over manual control. Two, 3, 4. Manual control engaged. You can see I'm holding control and the engine's holding just fine. I did need to just do a little bit of fine tuning there and we've got cut off. I was supposed to cut the engine off at 100 feet per second before the end of the burn, but I got distracted and went down to 0 instead. So here, motors off, servos off, safe the batteries, proceed. And yeah, we definitely overburnt that by 85.4. No residual trim though. So we'll disengage auto or disengage manual control. Standby off. Attitude deadband max. Translation off. Direct power off. Rate 2. SCS direct ullage open. Pitch and yaw open. Proceed. Verb 82 enter. There, 240. And yeah, we're definitely a couple miles short. Thanks to my forgetting to cut the engine off at, it said to cut it off at the Delta V counter 100, but I went to 0. Force of habit going to 0, I guess, but we will we'll see if at 169 hours we'll need to do this again. We'll get a state vector update then, but normally when you're doing these manual control burns, you would bring it down to 0 and cut off. So for the purposes of the tutorial, I'd say that's good. So thank you for watching. All right, recording done. Now we can engage chill mode. So we'll go SCS and we'll go wide deadband hold. Now we're just going to let pitch go. Pitch and roll. Now we'll let yaw go. All right. I'm actually going to make a manual save here because I don't want to invest all this time doing all this stuff just to not have the state vector update work. So we are just going to let it drift along and see if we get a state vector update. And if we don't, then we'll redo the manual burn, of course. 67. Here we go to 68. We did get a state vector update. However, I don't know. I don't feel comfortable with that. I want to do that again. That manual burn. So let's see if I have a quick save. That is, nope. Okay, so we got to go back and do it. That's fine. That's fine with me. I don't know. I just don't feel right about that, how that burn went. That's the benefits of running the sim, I guess. All right, we're up. I'll speed this along. One 65, 17, 6, good. Delta V's, good. Take 2 at the manual control burn. This time we will absolutely remember to shut the engine down at 100 feet per second remaining and not 0 feet per second remaining. A silly mistake on my part. Yeah. Okay, there we go. Okay, yeah. Doing the manual control burn. Again, we always start off testing our caution warning lamps, and I've already done the P30 and the program 52 IMU line because that's something that doesn't change with any burn, and we've done a lot of those. Our condition lamps are good. We'll set in the delta V now, and yeah. Last take I did this, I cut it off too late. I accidentally cut it off on the 0 mark, but instead we're supposed to cut it off 100 feet per second before the 0 mark. And I knew that. I just lost track of the delta V. I was focusing on maintaining attitude instead. I am doing great, and I am very much ready for the weekend. I'm kind of actually really embarrassed that I have to do this burn again. Verb 24, enter. 10102, enter. 11111. And our weight is 30,000, what was it, 656 pounds? Yes, 656 pounds. And our trim, minus 00078, enter, minus 00045. Proceed, verb 46, enter. There we go. Now we can get a clock started. So we got 45 minutes. 10, 20, 30, 40, 1, 2, 3, 4, 5. 1, 2, counting down. Mark. Proceed. There we go. And now we will begin our orientation into attitude shortly. We will just let this thing drift along for a bit without entering gimbal lock. We're actually floating right to our burn attitude, so I'm not disappointed by this development. Now is as good a time as any. There we go. Look at that. Verb 41, noun 91. Last time we did get the issue where the attitude of the star was covered behind the Earth, and this is because the mission control that NASP has is our own script and not something we've recovered. Because in real life, mission control is done by people, so a program it cannot factor for the Earth covering the window, but I'm confident in this burn attitude. So we'll leave it as is. And we are going to transfer attitude control to program 40 now. That's good. And we'll plug in our circuit breakers. And we'll bring it down to the 6-minute mark. Your trans Installation control, power on. Yep. Bring it down to 6 minutes. Six minutes. Main battery ties on. Thrust vector control servos on. We'll reseat our trim. Switching to AC only. Attitude 1, rate 2 on SCS. Take her down to 5 minutes or so. 5 minutes. Pitch motors 1 on. Manual thrust mode engaged. No thrust control. Good. CMC attitude control and gimbal motors 2 on. Check our trim. Trim looks great. Pad values are minus 5, 6, 7, 8. And minus 5. And we do have manual thrust vector control. That's good. And by the way, the engine, it does actually move. As you can see, pretty cool. Go back to neutral. Disengage manual control, normal and direct on. And we'll send attitude control back to program 40. And we'll get it rate attitude 1, rate 2. Bypass the alignment and begin the trim check. Rate goes to high. And bring it down to 2 minutes. Oh. Unpause the recording at 2 minutes. There we go. Sorry, it's also recording the manual control tutorial at the same time. Let's see. Let's read this. Good to hear you're doing better than me. I'm now learning how to do stuff with Gemini and reentry so I can get to rendezvous and docking. Still suck at coming down, though. Keep landing by Australia. Yeah, reentry's landings are difficult. We'll say that. And that's because they're not calculated for you. The best thing I can say is, like I don't remember exactly when it was. It was like an hour? You're going to want to target your reentry at some point, in between Asia and America, and you'll do your retro burn there, like halfway in between or so. And then by that point in time, you should be re-entering near the west coast. And you'll hold a lift vector up initially. And then when the sort of G's build up and they start calming down, then you can do your lift vector control reentry. For rendezvous and docking, I do have a video up explaining a few tips on how to actually do that. Back to the tutorial. All right, so we're at the 2 minute mark now, and we will arm the thrust. This thrust is armed, and we'll bring it down to the 35-second mark. I do have the event timer going slightly faster than the computer so that when the engine ignites, we can flip the switch up and start the clock immediately. So we'll just actually give it a couple seconds of grace period now that we don't need it anymore. 35 seconds, and we get the disky blank. And at 30 seconds, we'll get the EMS to start monitoring. "20 seconds. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Standing by for manual control. So in manual control, you're definitely going to want to be holding control the entire time while you're gimbaling the engines. Manual control engaged. It's 8, 2, 1, and 3. When you get far off, just simply give it a jerk like that. And so 8, 2, 1, and 3, and you keep the needles as center as you can. 400 feet per second remaining. 300. 200. 100. We'll turn one of them off, slow us down, cut off. So you can see it's very difficult to do this, cutting off the engine while maintaining attitude. So I hope that our Delta V, our burn has been good overall. So engines are safed. We'll take the gimbal motors off, the thrust vector control servos off, main bus ties off. Proceed, and let's check the residuals. And they are so much better than last time, so I'll take it. EMS function off and standby. Attitude deadband max. Translation off. Rotation direct off. Bmags to rate 2. Pull our circuit breakers. Proceed, and let's check our orbits. 123 or 239.6 by 89.2. That's great. Proceed, 0, 0, and disengage manual control. And that's all. The engine's saved, and the program 40 will update the state vector. Thanks for watching. All right, that tutorial video is done. Okay, thanks for the advice. Been watching all the videos I can and trying to get better at timing all maneuvers because that's my biggest struggle right now. I'm grateful for your videos and the official reentry ones. I'll be spending the weekend practicing so I can eventually fly Apollo, my ultimate goal. Yes, Apollo is absolutely stellar. And once you've learned Apollo and reentry, you should come to NASP. It's easier in some ways and harder in some others. Okay, so we'll scoot along now. Let's go SCS wide deadband hold. And we will not hold pitch or roll. We could see that air resistance, it really tumbles us around. It does a pretty big number on a spacecraft. Let's take a look. And we've got stars. That's actually perfect. Verb 37, enter. 52, enter. And we're going to do option 2. And our GET is 167, 26, 0. Looks good. And we've already verified star sighting. And now we can engage wide deadband hold. Star 41. That was bad. Mark. One of the things I do like about this is this P52 is actually way easier than in reentry. I don't have to touch anything, and the computer will find the star for me. This is something that, to my knowledge, reentry doesn't do, and they don't have these really nice overlays on the stars. It's just sort of guess which star is which. Of course, you can mark any stars that are 30 degrees apart and then change the marks, but you really should go with what the computer has calculated for you, because those are going to be the best angles for the trigonometry to work out. As I said, there's conditions. The stars have to be at least 30 degrees apart. And you need to have spotted more than just two, because the computer is not going to like it if it's just two stars in the sight and Earth takes up the rest of the view, right? The computer is going to hate that. It needs, it's a 60s technology. It needs a really good reference point. So we are coming up on our PTC initiation test with a T0 of 167.00. Let's go up, and we can clear SPS 5. And our PTC is at 167. Zero, 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 zero. Yes, it would be very nice. That has been one of the most headache-inducing things about reentry, is the fact that, not having an overlay is fine. I can do it without an overlay in here. But it's only because the computer can find the star for me. The non-existence of an overlay or the option to have the computer find the star is an absolute P52 buzzkill in reentry. There we go, 166 and 10. PTC initiation test. So go poo. There we go. Very low. So we're all set up for that CMC auto. 62. Verb. Oh yeah, another thing that's not in reentry is, check this out. If we had verb 61, the needles change, and instead they display commanded rates. Verb 63 will be, I think this is attitude from local vertical, but I forget. It might be from this. Verb 64 is the antenna thing. Verb 60, was it? Yes, verb 60 shows attitude from an orientation when you keyed verb 60. Verb 63 is, I think, the same thing. Verb 62, enter. And then we get the commanded attitude from desired orientation. These are things that reentry, I believe, also doesn't have, which can help out a lot. Because when you're docking, you can key like verb 61 with the attitudes from from the time you keyed it. And then when you do your pitch around, these needles will actually recenter every 180 degrees. So when you do your pitch around, you know exactly when 180 degrees is without having to actually read the ball intensely. So this helps out a lot. Yeah, reentry needs a little bit of work, but NASP has been in development for a lot longer than reentry has. NASP has been in development since Orbiter 2010, and Orbiter itself has been in development since like the 1990s or so. It's been in development for decades, over 20 years at least. In reentry does not use real code, and you can tell because reentry is actually bought at a price. Anything that uses the real Apollo code has made a deal with the museum, and the museum will never, ever, ever let you sell. I was going to do a tutorial on the PTC here, but I think I won't because it's actually significantly different than any of the other PTCs. I think I'll do it in Run with Apollo 11 or something. Oh yeah, this is a that's LOI limits. Oh, one of these has it. There we go. This is a very helpful piece of sticky tape. This shows you where everything is. So you know which antennas, where the high gain is, where the quads are, where the transponders are, where the windows are. It's very, very helpful. Where the water dump, urine dump, and steam vent nozzles are. Yeah, this is about the most helpful piece of paper there is. There's also papers detailing aborts. If the game was for the people, could he use the real code? Yes and no. Yes and no. Legally speaking, absolutely. Technically speaking, no. His engine, I don't think would support it. There's not enough physical hardware simulated, right? The hardest thing about NASP, and I've been told, the hardest thing about NASP is the or the hardest thing about making NASP is actually convincing the computer that all of this hardware is real. This took years because without the hardware, the computer is going to flip its shit, right? It's going to give you program alarms and just not work. It's going to give you program alarms, things aren't going to process correctly, and it's going to be broken. Everything in here has to physically, the spacecraft has to believe that it really exists. And so all of this logic, all of these like ICDU, the gyros, the GDC, all of this stuff actually physically is coded to make the computer believe that it's really there. And that would take that would mean that reentry would have to start essentially. Yeah, that would be a huge task. Because it's not just, oh, we'll plug in a computer and here we go. It's way different than that. None of this stuff is plug and play. How big is the team behind it? I think it's like 10 or so people. It's pretty big. It started out with just like 1 or 2 people, but over the years it's accumulated a large number of people. The Wi-Fi AGC is actually developed by NAT developers. That Wi-Fi AGC that was showed off in reentry with their UDP protocol, that was made by NAS developers, and it also works here. One of the devs named Max Q, I hang out with him a lot. He was trying to set up the Wi-Fi packets for it, and I had to break down how UDP packets are formed and what actually goes inside of them, because he had a lot of missing stuff, and he really appreciated the help. So that was a proud moment for me, because I haven't been able to help this project out in the slightest. I don't know anything about computer science. My degree's in information science, so they didn't know about Wi-Fi, and I don't know about how any of this computer works behind the scenes, so that's good. We help each other out. .3 degrees per second. So let's do... fine-tune. There we go. 0.3 degrees per second. Wait for time 0 plus 26 minutes. Certainly. Yeah, this is about the least fuel efficient PTC ever because of the air resistance. We're gonna burn a lot of fuel doing this. I am a little worried about my RCS quantity. Very worried, in fact. But I should be able to pull it off if I just cut a few things from the flight plan. Some of that non-important stuff that we've already done, like P-22s and P-23s, that become non-stop after the 170-hour mark. Yeah, this is Orbiter has become one of my favorite space games. I used to not like it, and I prefer Reentry, but this is the NASP mod and the Vostok mod have absolutely just blown my mind and completely changed me. I'm actually happy to be alive in a time where NASP is in development and not gone and only recoverable by the Wayback Machine, or worse, not recoverable at all. So this is a good time to be alive. If I had to pick, though, I would live in the era of warp drive technology if it's even possible and happens. Star Trek Enterprise, the OG, is absolutely one of my favorite shows ever. And I would love to be on a warp mission. Yeah, so now we're just vibing along, essentially. Doing the funny spin as we drift along into the cosmos. Okay, terminate PTC. Easy. Verb 16, noun 20. Enter. It's A, B, A, B, A, B, A, B, B, A, B, A, B, A. Null rotation. Always wants to do this. There we go. Rotation nulled. And we'll shortly begin our SPS propellant thermal control test. Engine pointing away from the sun. Right. It would help if I knew where the sun was at this point in time. So pause camera. We are going to target to the sun. So the engine needs to be pointing this way. So we will do a nice yaw maneuver with a little bit of pitch in there. It was really white in real life. Yes. It was indeed really white in real life. So let's get a little bit of yaw in there. And now we just need a little bit of pitch. Yes, normally Houston would tell you what the test attitude is, but they don't for us, so yay. Why does everyone make it look blue? Is it just for looks? This, I believe this happened as a result of the Apollo 13 movie. They made it blue in the movie because it was easier for the cameras of those time to capture. The white would have blended in with the suits and people, the lighting. So they made a blue, sort of to stand out, so you could see what they were flipping. And because of that, everyone watching Apollo 13 was like, just they just made it blue after that. I mean, it looks really cool. I prefer the blue over the white, but the white is how it is in real life. But there is no denying that it does look really cool. All right. Engine is officially pointing away from the sun. SCS, altitude deadband max. Good. How much RCS did that expend? Not a lot. Okay. And now we get to watch the SCS temperature. Or the SPS temperature, that is. Yeah, well, the white still looks really cool. And in fact, I think the white is growing on me a bit. So, I mean, just look at that. And I mean, to be honest, in a space setting, the white kind of makes more sense anyways. This is so visible even in the sunlight, whereas the blue would have a little bit of trouble with that. So it makes sense. I do like the look of the blue better, but the white it's still good. I like it. How's our engine temperature doing? It's holding pretty nicely, actually. Yeah, it's making that an option would be incredibly difficult because just getting these lights in here was like a 2 or 3 year project because of how finicky orbiter lighting is. For instance, where's the moon? The moon's gone already. When you press F9, the lighting of things actually changes so that you can see far away objects better. And as a result, this can do some pretty wacky stuff. Yeah, it looks like they fixed it here, but if we look out the window, yeah, they also fixed it here. Well, when we have the docking probe attached, the lighting does break. So we'll see that at some point. But just getting the white was a hard task. Orbiter's kind of showing its age. It's, it's a few decades old. We end the propellants control demonstration in 2 hours. So one more orbit, and it'll all be over. I gotta say, the temperature has been holding very, very nicely. It has exceeded my expectations, and so doing burns when we're pointed away from the sun or on the dark side of anything will be no problem at all. It will retain its heat once preheated. And we can see that air resistance is really knocking us around right now. Doing a bit of a number on the RCS fuel as well, but it's alright. We'll be powering down shortly. And the SPS propellant temperatures are holding very steadily. It's only dropped by about 5. It's only dropped about 10 degrees, so that's good. Yeah, I wish there were more realistic space games too. Orbiter is just such a good engine, though, overall. It has its quirks, but it is a good engine. So it's like, why make your own when the engine's already made? And a lot of things are a mod for Orbiter. I was looking into Space Shuttle Ultra, and it's actually discontinued now, which is unfortunate. I'm going to see if I can download it. Space Shuttle Vessel is its replacement, but it hasn't gotten updates either in like 2 years, and it was actually an older version of Space Shuttle Ultra where not a lot of stuff actually functioned good, so a rather unfortunate set of circumstances, but that is okay. I have a game that is not as realistic computer-wise. It still has the interface with the computer and everything, but it's not as realistic computer-wise. You're not calculating your own burns and stuff. But there's a lot of missions you can do, including missions where you're docking stuff to the ISS. So I'll show that off after my Apollo stuff is done. Warm up, warm up. We're off. Off. Yeah, it's unfortunate. Honestly, I was hoping for Space Shuttle Ultra to be more realistic than it is, but I might just be spoiled by NASP. You've seen it but never played. Yeah, I like it. It has a lot to offer. It's pretty good. All things considered. But I think the most realistic space shuttle game, one of the most realistic, has got to be the 1998, it was 1996 space shuttle game by Virgin Games. That's got to be my all-time favorite space shuttle game. I don't have it anymore, unfortunately, and it ran on floppy disk, so. But it was absolutely amazing. 3 dimensions, unique art style, it had interactable controls. All that was in there. 3D cockpit. It was like Microsoft Flight Simulator, the original, where it's like a 3D cockpit, and then when you clicked on a panel, you went into a 2D cockpit, and you could flip the switches. Exactly like that. There is not a lot of gameplay at all, but it's Space Shuttle, Virgin Games. I think it's just called Shuttle. Shuttle. Yeah, it's released in 1992, platform DOS. Here, I'll put a link. Have I ever played Apollo 18? No, I haven't. Commodore 64 game. Oh yeah, this was mission control in the ESC game. Oh, that's the Gemini spacecraft with an S4B apparently. Interesting. Yeah, this is quite interesting. Not entirely realistic. I mean, Gemini could have gone to the moon if they worked hard enough, but it looks like it's not even really. It looks like the Nova rocket with a LEM inside. Interesting. Well, this is very obviously modeled off of the Gemini spacecraft. Yeah, right, let's cruise along to our O2 purge. It's nice not to have any guidance and stuff powered up, so we can really just drift along. It's nice. I completely skipped the O2 purge. Schedule 30. Yeah, we could do it now. 171.53. Whatever. That's fine. $55. 10, 20. Okay. Oh, another game I've been really liking recently is I've been thoroughly enjoying Deep Rock Galactic. That has been an absolutely stellar game. Repetitive, but still fun. And simple. I could turn my brain off. So after this block data, it'll be an ECS redundant component check. Secondary loop tests, inverter changeover. That's fun. And we'll be repowering up at 192 hours for actually literally nothing. We power up just to... Oh, yes! No, not nothing. This is the backup IMU orientation and backup IMU realign. Absolutely will be doing tutorials on those. Some of my favorite procedures, and I'll need to practice finding the stars with the fucking optics. Yes, star marking is not just done with the sextant. It's also done with this little doodad. Here, the crew optical alignment. The crew optical alignment. What did this stand for again? I literally just watched a video on it. It was crewman optical alignment site. That's what it was. Yes, crewman optical alignment site. There is only one IMU. Well, technically, there's two. There's the IMU, and then there's the BMAGs, and the whatever the SCS has. But there's backup. The backup IMU is not a second IMU. The backup IMU alignment is telling you that it's the backup method of aligning the IMU, as opposed to the backup IMU itself. This second ball with the GDC stuff down here, that's the backup for the IMU. This is the backup for this optics here. So this is how we'll be aligning stars, or doing our star alignments coming up here. And that is a really fun procedure. While we're chilling, I'm going to actually upload that manual burn. So let's do manage videos, dashboard upload. Follow GNC tutorials. SPS burn manual takeover. PS use CTRL 8 plus 8 2 1 3 for fine tune control, and just 8 2 1 3 for course control. Follow GNC tutorials. No, it's not made for kids. And now we'll just let that upload. All right, it's coming up on ECS redundant component checkout. So 174. So 8, 9. Here we go. Switch to other suit compressor. Never interrupt the operation of the system. Always turn it on and then turn the other off. Good. Good. If you're wondering what I'm checking for, if you look at this O2 flow here, you'll see it bump up and then down. And this is the pressure regulator checkout. So you close one of the regulators, you stop it from operation, you select the functioning one, and then you test it. You stop the other one, select the other one, test it, and then you just set it back to both and leave it as is. And then we're going to check out the secondary coolant system real quick, just a quick 5-minute test, and we'll do a more thorough test later. So we'll see our accumulator quantity drop, and then our discharge, our pump discharge pressure rise. There we go. And stable. And now when we begin boiling operation, we'll see the steam pressure drop from the peg position down to the actual reading. And we'll see the evap temperature start to fall. And this is what we're testing for. After 5 minutes, it should be between 38 and 50.5 degrees. And it should prove that it is holding temperature nicely by regulating the steam pressure. And we can see it is indeed holding the temperature. And this means we have a good secondary loop. So after 1 minute, or sorry, after 5 minutes of this small verification, we then are going to go to the steam pressure control and reset. And now the steam pressure will hold and the temperature will continue to rise. And we do this for a minute, at least a minute. And then off, the steam pressure rises again. The temperature will rise a little more. And then we turn the pump off here. And the spin down will happen, where it will gradually fall to 0 discharge pressure as the pump stops spinning. Here, we can actually watch that. There we go. And of course, it'll never actually hit 0 because this is a dead is 0, not alive is 0. So the difference is that the gauges will only show 0 when the power is turned off. If they're not turned off, the gauge will always be above 0, even if it is actually 0. Live 0 has it where the gauge will be at 0 if it is actually 0, and when powered off, will go and max out in the either the opposite direction, or will also be at 0, and that is kind of a bit of a problem for some plants. The live 0 is older, less used because of its problems. And, well, it's not really problems technical wise, it's problems logistics wise. So how do you know if it's on or off? If it's actually 0 or if just the gauge is unpowered, and this can kill someone if they're messing with the gauge and they think it's off. So dead is 0 is now the preferred way to do things. Whee! I still think that this hatch just chilling here is kind of cursed. It looks really weird without the probe. Spacecraft also looks really weird without the high gain antenna. It never flew on Apollo 7, which is why we don't have it. So it looks really cursed, the Apollo 7 system. Okay. We're approaching the 10th period of activities. I would love to do the backup IMU orientation and realign today, but we might not get it today. We'll see. The next power up we do after that is going to be at 205 hours. And we'll do, it looks like one final burn. And then a ton of landmark tracking. And then we power down. We power back up at 233. And it looks like, nope, another burn. So it was not the last one. And then that's it. We cabin cold soak. And then we power up one last time and do our deorbit. So it looks like we're actually pretty decent on RCS fuel, all things considered. We might not even hit the 50% mark, but we'll see. Yeah, the antenna's missing. It didn't fly on Apollo 7. There was no point. You're really close to the Earth. So the omnidirectional antennas provide a good enough bandwidth. In fact, you'll never see You'll never see bandwidth so high. Let's see if we can't acquire on something. No, we don't. We are not in signal right now. Oh, yes, you'll never see bandwidth this high ever again until Apollo 9. Apollo 9 does bring the high gain antenna, though. I think for testing, it's stowage in with the LEM and the high gain antenna procedures with the LEM attached and stuff. But yeah, if you haven't checked out my rendezvous with the S4B, you absolutely should. It's a thrilling experience to actually. That was my second time rendezvousing with the S4B. Before that day that I recorded that video, I have never rendezvoused with it before. I always had to abort, and the problem is because back in the day, the optics only had a 50 nautical mile range for the overlay. And when it's over that point, it just looks like a star. So you really don't know which is the S4B. And even if the optics auto acquires it, it could just be so far away that you can't see it, right? Because it's not emitting light, it's only reflecting. So it's very faint. Sometimes on a low res monitor like I have, you won't even be able to see it. So I always had to abort. But now they updated it where the sextant itself, not the scanning telescope, but the sextant, has a really far overlay range. And so you can take really good marks and actually do the rendezvous now. Oh, yeah. And here's that lighting demonstration I was talking about before. Orbiter's finicky lighting. Here we can see the moon has funny light going on when we activate the overlay. Whee! So at 183 hours, we'll do a fuel cell O2 purge. And then we'll begin our secondary coolant loop test. And we'll actually, I believe we'll power down the primary loop. But can you place the experiments down in NASP or reentry? I don't know what you mean by that. My Apollo 11 video might not be labeled as NASP. I think that's what you mean. If I can mark the title as NASP or reentry. Going forward, I will. Those Apollo 11 videos were made way at the start of all of this stuff, so I wouldn't watch those. They're very shitty videos, to be honest. Not that all of my videos aren't shitty compared to everyone else on YouTube, but I wouldn't watch those. I'll do Apollo 11 again with more explanations and stuff, not just I'm flying and never talking. So we'll we'll get there. It took me a while to become a little bit more vocal. I'm still kind of quiet at the start of streams until I see the view count go up, because it's almost like, what's the point in talking at that point? But it's just a habit I've got to work out. But I will get to Apollo 11 in reentry as well. And I hope the lunar ascent has fixed by now. I stopped doing Apollo 11 in reentry because of problems with lunar ascent. So I hope it's been fixed by now. Or you just continuously fly off into outer space for no reason. which is weird because the ascent in reentry has always sort of felt on rails to me, like it's been guided. This is, of course, never on rails. So the ascent is continuously firing RCS like crazy. But in reentry, it seems very on a rail. So I was surprised when I saw that the engine wouldn't shut off, wouldn't run out of fuel, and it would just fly you out into space forever. It was definitely crazy for me. Forgot the last few seconds of that purge. There we go. 183.40. And we're going to take down the primary loop and initiate our secondary loop test. Yes. Can you do the experiments? No. Unfortunately, none of that stuff is in. I know that the devs are, I believe, in NASP, they're working on an ALSEP. They're also working on making the Bliss backpack. They already have the lunar rover. More simulated than their entry as well. But no, you can't place the experiments in either of them, unfortunately. Right now, their main focus is Skylab, if I remember correctly. Skylab and a couple of CSM overhauls. Different things with the ECS piping. Like they just redid how the fuel cells work. So the fuel cells are ultra realistic now. Like they're realistic before, but they behave exactly as they did in real life now. I think the last biggest thing they're going to be working on is this direct O2 valve. The pipe is smaller in diameter than it was in real life, and so in the startup it tells you, oh, open this to just pass halfway and you'll be at like here, when in fact if you open it 2 clicks you go way up there. So the diameter of the line is different, and so these sort of overhauls are their biggest priority at the moment, since the CSM is way older than the LEM. The LEM is only like 2 years old, if I remember correctly, 2 or 3 years old. So it's very ultra realistic compared to the CM, and the CM is very ultra realistic compared to reentry. So if you can like feel the difference between the LEM and the command module is a big difference in realism, and the difference between this command module and reentry is like, it's crazy. So that's what they're working on. They're sort of working on getting the command module up to speed with the LEM. Not that it really needs it too much, but it's always nice to have more realistic stuff coming out as they learn more. The biggest thing I can't wait for right now is the space shuttle in reentry. That's going to be huge. Space shuttle and Apollo 13. I also love Apollo 13. Does NAS have failures? Yes. Yes. The S4B failure was actually caused by lag. It was not caused by any random system failure. That was 100% caused by lag. I had a jump in lag during the staging, and that caused it. And I figured I'd go along with it because sometimes the glitches are a blessing, and it's really awesome to experience something like that. So I went along with it. But by the time I splashed down, I was pissed because I had been working on that pre-launch procedures for a few hours at that point. I was doing that in real time, the pre-launch procedures. I like doing it in real time with the countdown going. It makes it more dramatic. So I was pissed at that point. But there are failures. They're not random, though. You have to trigger them. You can turn on random failures in orbiter itself. I don't know if that'll actually trigger any of the failures on the spacecraft, but there is a failures window that you can interact with and make different things happen. And you can simulate the lightning strike. You can simulate the Apollo 13. Yeah, thank you. I wanted to go along with it because it was admittedly cool, but I don't know if you could tell I was absolutely pissed. Okay. Secondary coolant loop activated, and we will deactivate the primary coolant loop now. So H2O flow off. There we go. Steam pressure manually increase for 1 minute. Yeah, that abort, at the time it sucked, but that abort is easily one of my favorite videos up on the channel. It was good. Yeah, it sucked, but I wouldn't have it any other way, because that's one of the 2 reasons. Watching that video is always great fun, even though I wasn't very talkative because I was so upset. But also, that was one of my most viewed videos, so people love a good random disaster, especially when you're not expecting it, right? I was like just flipping between the inside and the outside, like what the hell do I do? And I was like trying to separate, but then I was like, wait, but I have to plug in these circuit breakers over here, and then yeah, it was I definitely didn't have an abort checklist. That was completely off the top of my head. I made it up. And I asked the devs, and they said I did a pretty good job. One of the things I didn't do right was I should have been using the SCS to hold attitude during the staging, but I thought it would be fine to use this lever to engage the thrusters to just make me spin around to the retro attitude. Then the other thing is that I did the docking probe too late. I should have done that before ditching the SM, but otherwise it was executed flawlessly, is what they said. So I was happy with it, and people were happy to see a random lag-caused failure. So looking back on it, it was fun, but at the time, it did suck. So yeah, the primary loop's deactivated and the secondary loop is up, and we're just checking how things are holding. Let's see if we get any caution or warning lights at all. I can tell you that oh yeah, back in the days of re-entry, the chute's opening was a huge problem. Even if you had all your pyros turned on, there was just like, for whatever reason, the chutes would just absolutely refuse to open at all. You had your ELS on, your pyros on, and it just, that was making me so very mad. I didn't play re-entry for like a few months until that was fixed. But yes, as I was saying, I can tell you the exact amount of watts, thermal watts, that the environmental control system is putting out. Right now, the primary is putting out apparently 2,489 watts of energy and increasing, and the secondary is between 57 and 37. But over time, this will be shifting because we took off the primary loop. Yeah, temperatures are holding really nicely. So it looks like our secondary loop is more than capable. Yeah, good mission so far. Yes, I agree. One of the more boring missions, but necessary because it has all the crazy tests and stuff. I do like them, and eventually, after I finish my guidance and navigation series, I'm going to do a general keeping the spacecraft alive series, sort of explaining how power is produced and things like that. And I'll be talking about the regular procedures, the fuel cell purges, the activation of the secondary loop, primary loop, stirring the tanks, doing a H2 purge, talking about the inverters. Yeah, I'll talk about that stuff. It'll be a very short playlist compared to the GNC playlist. So it'll be nice after I finish my GNC playlist, sort of tone it down. And I don't know. I might make a poll and I might ask if people would prefer that before the LEM GNC playlist, or if they prefer the Lunar Module GNC playlist before this sort of more technical stuff. Yeah, that's the hope. Getting new people to play this. Steal them from reentry. No, I'm just kidding. Reentry's good. Every beginner should start with reentry. I've always said that. Reentry has been the start of my love of space. I remember when I was young, and I was working at McDonald's at the time, I want to say. And I got my first paycheck. And I bought reentry on my laptop. And it was running at like 10 FPS in Mercury because it was so unstable and my laptop is so shit. And I played it at 10 FPS and I loved it, and I could not do Gemini or Apollo. And when I finally got my first gaming rig, which I built out of computer parts from the junkyard, and I finally was able to do Gemini and Apollo at 30 FPS, Gemini at 60. I was so happy, and this got me through a lot of bad times in my life. And it's ever since then, like, reentry has been the very first thing I went to. I had Orbiter before. I messed around with the little space plane, but it was at that age, it was too hard for me to manually calculate burns and stuff, so I didn't really play it. Yes. Hepleg would request the LEM GNC before the CSM systems tutorials. Okay. The CSM systems tutorials is honestly, it's not that bad. The checklist tells you exactly what switches to flip and in what order and when. So if you just follow those, you'll be all right. You don't really need to know anything about the systems, but I figured it would just be nice to sort of explain what it does at a basic level. But so people love the GNC tutorial so far. So thank you very much. Here we go. Inverter changeover. Right, so let's just talk about the inverters real quick. So the spacecraft, of course, as you know, it has no solar panels. Its power is a fuel cell, so a chemical battery, which operates by fusing hydrogen atoms and oxygen atoms into water molecules. And this happens with a catalyst and electronegative gradient. So as the oxygen is flowing in, the hydrogen is flowing in on the other side. And the catalyst strips the valence electron from hydrogen, which makes hydrogen positively charged. And oxygen is extremely electronegatively charged, so it sort of wants to pull the hydrogen towards it now that the valence electron's gone. It wants to be attracted by magnetism. So the hydrogen comes through and it goes through the semi-permeable cathode, anode, and catalyst to the oxygen side. And now that the hydrogen is over by the oxygen, the electronegative gradient, because there's two hydrogens for every oxygen molecule, shifts to being positive, which wants to pull the electrons in now. Now it wants to attract the electrons. The electrons are then captured by the cathode, and they whiz around all the spacecraft wiring, the 500 miles of wiring that are in the spacecraft. I actually think it's more around 5,000 miles of wiring, but it whizzes around and then it spits it out on the anode side. And then the hydrogen and the valence electron refuse together back to stable hydrogen, and then bonds with the oxygen and makes water. And this is how that fuel cell works. And this produces DC current. Because it's a battery. It's direct current. It's directly powered by the electrons. So this makes DC power. And all of these gauges and stuff, they all require AC power, right? So here you can see there's a ton of stuff that says main A, main B runs on DC. But look at this. We've got AC EPS. We've got all the signals AC. What else do we have that's AC? We've got all this guidance power is on AC. We've got the loop has AC, so the fans are AC. We can even see the individual phases for the fans. Fans run on 3-phase power. We've got the battery charger runs on AC. We've got a lot of stuff that runs on AC. All of these gauges run on AC. But I don't think we have circuit breakers for the individual gauges, just only the whole system. So a lot of this stuff down here also runs on AC. Here, let's take a look. Here we can see all this runs on AC. So there's a lot of stuff that runs on AC. So what we do is we take this DC power, this direct current, which is a flat line at whatever voltage. Flat line at whatever voltage. And what we do is this inverter, what it does is it shifts the DC voltage down to the 0 line, and then it adds a sine function, and it raises the amplitude of the sine function to the voltage of the AC. So the AC voltage we can see is approximately 115 volts. So it's going to add 115 to the amplitude, 115 volts amplitude. And so now we have this rise of 115 and we fall to minus 115. And this is called alternating current because it alternates between plus and minus. So this DC power sits at like 30 volts, we'll say. So it's just a flat line at x equals 30. Then it brings it down to x equals 0, and then adds a sine function so that it rises up and then down. And this is how the inverters work. So we're going to switch over now we're going to test the backup systems. So we're going to turn off the sensing circuitry on AC bus 2. And now we're going to take inverter 2, power off, inverter 2 off, inverter 3, and we can hear some of the stuff is powered down. Look at that. Gauges are powered down. We had our fan drop out. Now we'll take inverter 3 and we'll tie it to main bus B. So it's powered by main bus B. It's powered by DC. We'll take inverter 2. We'll untie it from the AC bus 2. And we'll tie inverter 3 to AC bus 2. We get the fans. Our gauges are back. And now we'll reset the sensing circuitry and we'll get an alarm, which we can acknowledge. And now we'll make sure that our phases show stable. That's good. Now we'll do sensing circuitry back off. Inverter 2 back to main B. Inverter 1. AC2 off. Inverter 2. AC2 on. Now we're running on dual inverters, and after this mission, they never did this because apparently it caused problems, and I don't know why, but they never did this after this. So test it, make sure it's stable, and then you take inverter 3 off and off. So on the topic of batteries and fuel cells, why did Apollo 13 get worried about having volts but no amps on one of the batteries during the command module power up for reentry? Right, so yes, volts is electrical potential and amps is current. Volts is a lot like pressure and amps is a lot like flow. I hate to use that expression because if you really sit down and think about it, it's completely wrong, but for basics, it's good enough. So when you're having all those volts and no amps, it wasn't that they were worried about no amps. It's they're worried about hitting a certain amps. When you're powering all this stuff up, if you hit a certain amps, you deplete the volts from the battery. So DC power allows you to have extremely amps amps. You can pull out as much amps as you want from a battery. The drawback is the more amps you pull out, the faster the battery drains. If you can max this DC amps out, and what will happen to this volts is, bam, it'll immediately fall to 0, right? And that will cause an overload, and you'll have huge problems. The battery will be dead, the equipment will be fried, and it's irrecoverable. And this is what they were worried about. They're worried about not having enough amps out of the battery with the volts they had left. Volts is your potential, amps is your current, right? So if you have a ball on top of a hill and the hill's coming down, that ball has a lot of potential energy. And when it's rolling, it has all that kinetic energy. Volts is that ball sitting on top of the hill, and amps is that ball rolling down the hill. So when you hit 0 volts, your amps will be the highest, assuming you've been drawing that much, and then amps will quickly fall to 0 as the battery's dead. If you can imagine this. But under normal circumstances, if you're just pulling out a few amps, over time the volts drain slower, right? So this is what they're worried about. They're worried about instantaneous discharge and frying everything because of the little amount of volts they have. So what they do is they reroute a ton of these circuit breakers with systems you wouldn't even know were involved with this kind of stuff. And they route it through the battery charger and in, and they reverse the flow. And now you can distribute the load between the main batteries and the LEM batteries. And when you balance the loads, you're able to power things up and you're able to sort of stabilize your amps and your volts. Then, when you've been running on balance, you've been saving power for your reentry batteries by sharing half of the load with the LEM batteries. Then you can cut it loose and at the point where the amount of volts remaining is sufficient enough for the rest of reentry. Yeah, you can only use so much of the batteries because they're absolutely necessary. If you ditch this stage, you're running on batteries. And so you need to have enough volts to supply the amps through the entire duration. It's all about time with this. So you share the load with the other batteries. It's not the amps itself they're worried about, it's the amp hours that they're worried about. So when they're going through the scene and they're like, oh, how many amps do we need? We need 4 amps. That's not 4 specific amps. That they need 4 amp hours more. So they balance the load with the LEM batteries until the right time where the amount of amp hours left in the battery, which you can figure out with the voltage, the amount of amp hours left in the battery was enough to supply them the rest of the way down without the LEM. That's what they're worried about. Good question. Good question. That took like 10 minutes of explaining. That was probably the best question I've had. But yeah, if you have little volts and you're trying to pull out all these amps like you are in startup, you can instantaneously discharge the batteries and fry everything, and it's really bad. But yeah, just think of amps and volts. Volts is your potential energy, and amps is your kinetic energy, and it sort of becomes a little more intuitive. It's more intuitive than the pressure and flow rate of fluid dynamics that the electrical engineers try to give you. Okay, very shortly, we'll be ending our secondary coolant loop test, powering up the guidance system for the backup IMU orientation and the backup IMU line. I'm excited, but also not excited for this because this backup method of orienting using the stars is a royal pain in the ass. I prefer the sextant marking and not using the coas, but for science, right? For science. Yeah, I hope so. That reload on that manual engine burn was embarrassing, but I only had 8.8% left. Or well, now I also have 8.8. I guess it didn't really make that much of a difference, but we were off by several nautical miles, so I didn't want to be that off. Here we go. Secondary coolant loop test is complete, so we will activate the primary coolant loop now. Stable discharge pressure. Stable steam pressure. And steam pressure controller in. And we'll take off the secondary loop now. 1 minute. Okay. And take off the pump now. All right. Secondary loop is powered down. Back on primary. Yeah, I'm just gonna be excited to have completed this mission for like a 5th time. This mission is getting a little old, but I always find myself coming back to it for whatever reason. Yeah, it's a lot for an Earth orbit mission, especially one where it's longer than a lot of the other missions because it's Earth orbit. It goes to like 200 and some hours. It's ridiculous. Here's our abort data. It's very confusing to read. I hate looking at that. Yeah, this is the landing zone 123-4A, 127-AC. This is the landing latitude, the landing longitude, the time you light the engine, the delta V you light the engine with. That's it. But it's just the format is ridiculous. They're fitting 6 things of information in here. 1, 2, 3, 4, 8 things of information in there. So the format is gross. All right, let's power up the systems here. No, I have the pads. I actually have the printout of the entire Apollo 11 flight plan. The block data pads were not too bad. She only got one of them in Apollo 11 though for the orbit, because the block data is only for orbits. She really only got one or two. So when you're at the moon, you don't use block data anymore. You use LOI abort pads, or yeah, LOI abort pads, and then when you're in orbit, you do your TEI abort pad. Okay, still lots to write though. Hate to do that under pressure like Apollo 13. Had to with gimbal angles, etc. after the accident. Yeah. The math with the gimbal angles is... The LEM is 90 degrees out of axes, but then you have to factor in like the gas does stuff, and it's not a good time. It's completely... The gimbal transformations are completely not how you would expect them. We'll just say that. Alrighty. Optical sensors, power up. Good. And let's assume control of this spacecraft. Good. Okay, I'm gonna make a save right here. You never know when you might crash. Right. It's a good time to begin recording. P53 backup method for IMU orientation. So we'll need to make sure we're operating on SCS, rate 2, and go to minimum impulse. For this method, we'll be acquiring the stars using the coas instead of the optics. Punch in verb 37, enter. 53, enter. Now we'll maneuver to acquire stars, and we do see stars. Proceed. Now we need to load the coas angles, the nominal coas angles. And the angle we have, the coas, is dependent on which window it's in. For the left window, the first row will be all zeros, and the second row will be 5, 7, 4, 7, 6. Now hit proceed, and you can take your first mark. Activate the star overlay.
Translation.
Verify rotation. And we'll begin acquiring the first star. Go pretty slow with this and take your time. Once the star is in the coas, you can begin to steady out by measuring the time it takes for the star to move between 1 or 2 ticks. And you know how many pulses you have. Once the star is centered, mark by hitting enter. If you would like to reject a mark, verb 32. And now we can bring the star back in towards the center. And mark. When you're happy with your mark, you can hit proceed and enter in the desired star code with verb 21. And you enter the 2-digit star code and enter. And now hit proceed. Now we need to find a star that is 30 degrees away from the last one. That program alarm was because I took mark with Q instead of enter. Force of habit. Hitting proceed here, just verifying the coas angles, and now we can go in the opposite direction, right? Because we're towards the Earth, so we'll need to acquire a star sort of pitching down more. And I will pause, and I'll be back when I've found another star, because it does take a little bit of effort to find the next star. All right. Here we go. Let's find the next star. I'm thinking we just took the mark on 43, so if we bring our pitch down, we'll come across to star 40 is right there. I want to say 40 is pretty good. It's not as far away as you'd like. So let's do this star down here. This is looking good over here. Yeah, that's good. Star, what is this, 35? Good. A fine selection. So we're back, and we're just going to, again, bring the star in towards the center of the optics. And right when it's centered, hit mark. So slow down. Center, mark. Proceed to terminate marking sequence. I also realized I accidentally double-clicked enter. That might mess up this. So we may have to do verb. Yes. Hooray for me. What was it? Verb. And this was star 35. Finicky program. I'll just have to do it again. All right, so yes, centered the star. Sometimes my mouse has a habit of double clicking, and it does really get annoying. Oops, 35, proceed. And we'll come to the next star now, which was more here. So let's do some more pitching down and acquire the next star. And it's all right. And I'll, of course, be back once I've acquired the next star. And I hate when that happens. Double-clicking mouse messes stuff up. What's another good star? Far we drifted, I think. What is that? Star 33. Yes, Antares. That's a good one. We'll take it if we can. But we might pass. It might pass Earth's horizon by the time we get it. Yeah, it's gonna pass the horizon. Damn, that's unfortunate. All right. It's a star 37 it is. All right, we're back, and we can see we've acquired star 37 in the optics. It is centered. We will hit enter, marking it, and we will tell the computer that we've marked star 37, hitting proceed, and we can see 7 is, all things considered, pretty decent. With the scanning telescope, the max error is 10, so 7 is better than if we did it with just the scanning telescope. Of course, that's not the case in real life. Usually, we're just, I guess, good. So hitting proceed, 0, 0, enter. And that is all. What a painful procedure. What do you think? I think these procedures can be rather painful sometimes. I'll make sure to title that video as well. It's kind of fun. I like the procedure, but that mouse double clicking enter really messed it up. It really messed up my vibe. P53 backup IMU orientation. All right, next one, P53. All right, or P54. Yes, P54. Backup IMU realign refs mat. So starts with verb 37, enter, 54, enter, and we'll do verb 22, option 3 for refs mat. Proceed. Verify we can see stars. That we can. Proceed. Same as before, we'll need to load the COAS angles. They might be loaded already. So 0170, we had the first, or 0106, we had the first star, and it's asking us to mark on star 6. This requires us to find star 6, which is somewhat painful. So we may be changing this up, but for now, we'll take it. And our angles have carried over from our P53 backup orientation, so we'll proceed with those two. Now we'll find whatever star we want. 37 is fine. And this is good if you don't know where the star is, like star 6 is located. If you're just doing internal only and you don't got your star chart like me, this is a good method. Just pick a star, mark, proceed, and then it wanted you to mark star 6, but you can tell it that you actually marked star 37. Proceed. And now you can find the next star, which is at least 30 degrees away. So we'll get maneuvering. And I think star 45 is bound to be good enough. So that was star 41. Yeah, if you just drift along, you'll eventually find a star you're looking for. And here, if we uncover the optics, we can see approaching us is star 02. So that's more than good. We'll bring it along. And center out. And once center, mark. Proceed. There we go. Forgot to proceed on the computer a couple times. It's okay. Bring it center. Mark. Proceed. And we did the mark on star 2. Proceed. So we can see really good accuracy with the COAS this time. Here's our error. Enter. And there you go. Backup IMU realign. Thanks for watching. Yes, it takes way longer than the optical realign. We're actually behind now because of those procedures. We're supposed to do a nominal realign. They don't tell us the time we're supposed to do the realign, so I assume it's the 35 minutes. So enter 52, enter. So we will assume that it's at the GET. That was listed. There we go. Now proceed. Ah, the comfortable optics. Much better. Program alarm, so hit the edge of the deadband most likely. Or it thinks it will, but I think it won't. Look at that. Much faster, much more comfortable. Now we're back on time. And we'll just cruise along. Till our wastewater dump. There we go. I think we are very soon going to end it here. It is getting mighty late for me. Most of my viewership is in the US. But that is not where I am currently residing. There we go. All right, so we'll do the power down, the purge, the component checkout, and we'll begin the stratification test. We're going to end it there after that. So I, for one, am going to use the restroom real quick. So I'll be right back. Okay, I've returned. And now the joys of doing something like NASP when you have a restroom break in your stream is you can actually vent the urine out to space. There you go. Very nice. The best feature, yes. Best feature in all of the spacecraft. Hands down. Alright, let's power this thing down. One of the things I don't like about NASP is everything's left click now. So you have to above or below like that. Makes it a little bit more difficult for people who are a little bit hand-eye coordination impaired. But it's to circumvent this glitch where when you're right-clicking and you zoom, if you interact with something that you can use the scroll wheel on, the mouse disappears. So that is why they changed it to that way. It's a orbiter bug itself that has been around for about 20 or so years. So yeah, it's a bad glitch. It happens on every spacecraft, not just this one. Computer off. Do they know what it is causing it? No. Orbiter's not in development anymore, and there's no way that they can themselves fix it. Open Orbiter, which is the open source code version of Orbiter, has a version of NASP that requires you to compile the studio visual code, and that stuff I'm not even gonna deal with the headache of that. Like, I've got to do enough of that already, so I didn't want to do that. And I like the officially supported branch is the most stable, so I like it. But I think in the open orbiter version that glitch is fixed. But don't quote me on that. Alright, O2 purge. So bring it to 2 minutes, 10 seconds. 6, 7, 8, 9, 10. There we go. 4 minutes, 10 seconds. Good. And 6 minutes, 10 seconds. Yeah, it took a lot of practice to be able to do this stuff this fast with just the left click. I hated it at first, but I got used to it, and it's fine now. I actually kind of prefer it. Blue ringtone, very loud. That's Roger DCS from the Gemini. I took that from the sound files in reentry. I have that as my ringtone now. ECS redundant component check, and then O2 strat test. Yeah, I don't know what kind of Apollo one I'd do for a ringtone. Because there's not like anything like Roger DCS or quick and simple like that. The Apollo comms are way more complicated in nature. Could do some go no go, but that's ridiculously long for a ringtone. And it kind of Roger DCS is kind of a joke as well because it's the digital control system uplink with the computer, so they uplink the burns and stuff. And so that's kind of like getting a notification on your phone, right? Whereas anything in Apollo involving the uplinks, they don't just say like Roger DCS or something like that, and they can't just like interrupt and be like, okay, we're gonna uplink to the computer whenever we want. Like we have to actually coordinate permission and stuff. The Switch are afraid of the Russians uplinking bad data, so the Switch is added. Because of that, it's not just Roger DCS anymore. So nothing short, simple, and sweet, and also a joke for those in the know. That's why I've chosen it. And it's very loud. That's like on quarter volume and it's that loud. At max volume, it's ridiculous. You could hear it across a building. All right, 197. We'll hit it with the test now. So the test starts out disabling the heaters and fans. And then you record the pressure and quantity. Make sure you're on tank 1 and not surge tank. See the pressures are just a little below 900. The quantity is almost 50%. And now we need to wait till the pressure goes below 850. So we'll time skip till below 850. At that point, we get the cryo press alarm. And now we turn the heaters on. At this point, you would write down the pressures and the quantities. And now it'll go up really rapidly. And once it's above 915, take the heaters off. And then the fans on. That was the H2 heaters, my bad. Heaters off. Let's not blow a rupture disc. Let's let that pressure come down a bit. There we go. And then the fans on. And now you're going to record the pressure and quantity for 4 minutes, once a minute. And we can see that the stratification, we can see the quantity is slightly different. And as the fans are on, these quantities are going to merge closer and closer together. Notice as we stir the tanks as well, even though the heaters aren't on, we do get some pressure. So we'll let that fall down. There we go. Turn the fans back on. And that's 4 minutes. It's good enough. Now we turn everything back to auto. And that's pretty much it. You can see now a lot of pressure in the surge tank after we did add a ton of pressure on accident. That's the second time I've done that, but it's not a problem. As long as it doesn't hit 1050, you'll be fine. You can see it comes right back down. And now we just drift along until 205 hours with a power up. And that is most likely where I'm going to call it for today. Yeah, because I'm tired and my throat hurts from talking. But we're almost at the end of this mission, almost at the final tutorial, and I may do the live stream for the reentry. I think that would be cool. I'll also be recording a video at the same time, but it'd be cool to see live reactions to the reentry. So hopefully I don't mess it up and reenter upside down or backwards or the wrong way. I've done that before. On complete accident by misreading the checklist. But I've done this enough times successfully that I'm confident. So with that, we'll drift along until our block data. Oh yeah, I'll do the rancher line, sure. Drift along to the block data, and I will see you all next time. Thanks for stopping by. I'll upload those tutorials.